Well, thank you everyone for joining. I imagine we'll probably have some folks coming in, but just as a brief intro, today's webinar session is between Cambridge Intelligence and Blackdot on the topic of how to basically use link analysis in combination with OSINT data in order to combat economic crime. For those that don't know me, my name is Alejandro. I'm a product consultant over at Cambridge Intelligence, and I'll pass it over to Brett, who'll introduce himself and talk about some housekeeping rules.
Thank you very much, Alejandro. Good afternoon, everybody. Lovely to meet you. My name is Brett Redmond, and I am an open source intelligence subject matter expert at Blackdot Solutions. I've got an extensive background in the public and private sector, and I work with customers, prospects, trying to revolutionize the way that we view open source intelligence through our platform, Videris. Before we get started, I just wanted to go over some housekeeping rules. So we will take the opportunity at the end to answer questions, but I just beg you please just to wait to the end because we'll make sure we go through them. So please, no questions throughout the webinar. Thank you. We head over now to the company intros, and I will let Alejandro introduce again Cambridge Intelligence.
Awesome. Thanks, Brett. Yeah, so Cambridge Intelligence has been in market for a while, and we provide basically graph visualization software development kits to help investigation software providers, ranging from intelligence all the way to cybersecurity, to create strong link analysis components. So if you've ever used a link analysis tool that can handle quite a large scale of data, it's likely Cambridge Intelligence in the background. I'll pass it over to Brett to introduce Blackdot.
Thank you very much. So we, Blackdot Solutions, we're an enterprise software company based in Cambridge. Our solution or platform, Videris, it's an all-in-one platform that revolutionizes the way that organizations and individuals and investigators manage complex and open source investigations. So Videris has been designed and directly attributed to the market of investigators and intelligence capabilities. Now it's being used globally across the public and private sector also. Thank you very much, and we will press ahead. So the first element that we need to discuss in this before we go any further, I think, what is open source intelligence? So open source intelligence is the analysis and collection of publicly available information. Now, this stands again for open source intelligence, or we use the abbreviation of OSINT. What this means for us is that we collect and analyze information in various different streams as to where we can find that, whether that's search engine data, news media, corporate registry, or publicly available social media. That can come across in many different forms in the way that we like to categorize them, such as structure, some of the ones that I've mentioned before in corporate registries, and unstructured data as well. Now, in this, there is methodology, of course, with anything, and tradecraft in terms of how we can gather this information. That can be various things such as web scraping, data mining, and text analysis. These are some of the common phrases more so that you hear within the realms of open source intelligence. This effectively helps us gather and process large volumes of data efficiently and effectively for the scope of the investigation that we're undertaking. Sentiment analysis, again, that's something that's quite key, but also trend direction is something that we're going to be using to employ qualitative and quantitative data when we're investigating publicly available information. So the scope of today, and Alejandro touched on this earlier, is that we're going to discuss the concept of open source intelligence and why in particular we think this has gained popularity in the context of economic crime investigations. Alejandro will then take back control, and he is going to go through a link analysis technology and how this can support successful open source intelligence investigations. Finally, I'll then take control at the end, and we'll look at how open source intelligence and link analysis combine for us to be able to create that perfect picture. Challenges in countering economic crime. So that there's various strategies that we find that individuals use, and there's three more so that we find that are discussed quite commonly, particularly within our landscape or particularly with customers or prospects that we engage with. Now, that can be various terminologies such as layering, structuring, an integration for individuals to hide illicit activities and to be able to blend illegitimate funds in with legitimate financial transactions. Individuals can use tactics such as false identities, nominee shareholders, and complex legal structures just to obscure the origin and destination of these illicit funds. What that also leads on to in the back end is the complexity of networks. Economic crime involves intricate webs of often very densely connected entities, individuals and financial transactions. Now, these are done deliberately with the scope of the ability to be able to leave these opaque, often spanning multiple layers through shell companies or proxy organizations, offshore accounts, and potentially nominee directors that we see across various different businesses. Untangling the connections and identifying the leaks can often be quite hard and quite difficult without the ability to be able to visualize these. The global nature of this is something that we're seeing every single day, whether it's financial intelligence or economic crime, however you want to phrase this. And cross-border investigations, naturally, they are more complex in the nature. Now, that can be access to relevant data. Now, some jurisdictions around the globe, or particularly within UK sovereignty, have private registries, so public-private registries that are only available to government factions or whether it's local law enforcement. Now, being unable to access privileged data alone, internal databases don't often give us the final piece of the jigsaw. Now, this is where we'll start talking about data fusion. I think the ability to be able to combine closed source with open source information or publicly available information, as we say, doesn't mean that it's just confined to specific regions. So in terms of limitations of being able to export data just from a local population, being able to utilize open source data and publicly available information means that when we're able to combine the two, closed source and open source, what we've got is data fusion, and that allows us to be able to look at the close intricate webs from a global perspective. That brings me on to slide 6. Why do we use open source intelligence to counter economic crime? So OSINT is effective across a range of use cases, particularly in the economic crime space, whether that's money laundering, fraud, sanctions, or investigators trying to find the crux of what's happening within these intricate webs or connections. Now, typically we find as an investigator, or through my past experience, I've seen usually that there's 3 elements again that we come across. Finding real world entities. Now, these are often hard to understand who's behind the company, particular username, website, or various other public or digital footprints that these individuals may have left. Often, this can be quite difficult, as I've touched on previously, when we're reliant solely just on closed information or accessible information that's only available to closed sources. Now, additional context to this when scaping through and trying to find these real world identities can often be the first pill that we start taking off that layer of that intricate web. This leads us on to understanding the networks. We often need to understand to be able to map corporate and professional networks to understand ownership. Open source data is essentially an effective part of that because we combine data from a wide range of sources. That's often the most effective way to be able to get a full picture, but to be able to give us as analysts and investigators the biggest scope that we're going to be able to attack these organizations or network physically from a jurisdictional standpoint. We can usually use 2 different elements when we look into this, and these are usually called network analysis. So in OSINT, I might use this to map out entities or to identify particular individuals that are relevant across more than one stream of my investigation. Social network analysis. So this quantifies and visualizes relationships to uncover hidden connections between entities, individuals, and start us to looking deeper and richer within those networks. Without the access to be able to do this, what this often leads to is investigators missing crucial parts or critical components of their investigations. Identifying risk. Now, we hear this a lot. Identifying risk, or those gotcha moments, and I use that in abbreviated terms. Particularly in financial services, we need to understand any risks that are associated with a client or a counterparty, just to ensure that we're not breaching compliance or regulatory compliance. In this case, data provided, or closed source data again, that I'll go back to, it is rarely enough to be able to give us a full picture of the risk. And I think that's why the ability to, again, fuse and review real world information or data that's occurring every single day, because it's live, we're able to view that, and to be able to marry that with the closed source intelligence, I think gives us a richer picture, whether it's a subject, a network, an organization, or a particular entity. Again, that this can lead on to particular issues. And these issues within open source intelligence is manual OSINT. Now, you'll hear the phrase manual OSINT a lot of the time. That's being able to visualize networks, entities, ownership, structures, corporations, or these very small niche businesses with officers or directorships that appear to not be visible behind the scenes of it. Now, what this can often lead to if we're conducting this manually is complex, messy data. There's also an element of where we need to discuss data volume. How do we wade through the sheer amount of data or information that we have that's available to us without an intricate way of being able to visualize all of that data? There's also a lack of professionalism, particularly within open source intelligence. Now, that comes from framework, governance, and policies, and something which I believe we're going to see later on in the year. There's often, within open source intelligence, a difficulty in collaborating with other investigators when looking at information or intelligence or mapping out networks. And that's particularly because unless you're using platforms, there isn't a way to be able to visualize this. Now, all of these examples that I've given you previously are only relevant to manual investigations. And I think what we'd like to be able to move on to is how we overcome these barriers. Overcoming barriers in open source intelligence can be due to big data analytics, the ability of data fusion, and collaborative tools. Now, we've touched at length at being able to combine internal data with external data, particularly open source intelligence and closed source intelligence, that's closed privilege information, but also the ability to be able to visualize this. Now, from an enterprise or large organization context, as we'd alluded to previously, this is a key component for anybody being able to visualize and map intricate networks. At this point, what I'd like to do is I'd like to be able to hand over to Alejandro, and I think he's going to go through a process and be able to show you how we can start forging this and make this look like it's a story or an artistry note to tell.
Yeah, no, thank you, Brett. A super helpful introduction as well into OSINT in general. So what I want to do for this section is basically talk about. I realized if your mic, Brett, it's been echo.
That's fine. My apologies.
No worries at all. Sweet. And can everyone? It says someone mentioned they couldn't see the slides. Can they see them all right? I wonder if it might be a singular issue, but okay, thank you. Might be a problem with Philippe on his side. Thank you, Aurelio. Just to trudge on, so when it comes to link analysis, I want to talk about the overall history behind link analysis in general, how it came to be as it is now, but also a brief overview. When you hear talks about link analysis, it often overlaps with conversations about network graph visualization or its graph visualization in general. And these are all different terms talking about the same concept. You know, it's basically taking these different entities and styling them as nodes and revealing the links between them as links. And the main focus is trying to flesh out these complex connections to one another. And oftentimes the link analysis components within your investigation tools are built on graph visualization libraries like the ones that Cambridge Intelligence offers. And some of the GIFs that you're seeing on the side are actually examples of what can be built using these different toolkits. So the history of link analysis is actually quite interesting, as it was originally a discipline that eventually evolved into a digital tool. So for instance, I want you to imagine like an investigator with a cork board with different pins that are then tied to one another using a red piece of yarn. And that's a very early example of what link analysis was like prior to becoming a digital tool. And its earliest adoption was actually in the defense domain, largely for intelligence investigations, but it's since been adopted across different domains that we'll go into in a second. And the reason for this adoption is largely because it helps give investigators the full context of what's going on in their data. You'll hear the term like a single pane of glass view quite often used to better understand this. And some of the examples of how link analysis is currently used, obviously when it comes to fighting economic crime, it's visualizing fraud rings and the money flows between different financial entities. But there's also things like communication activity, right? WhatsApp messages, social media activity, phone calls, emails. These are some of the common ways that people try to map out the connections between individuals. There's also organizational structures. In the context of organized crime, it's important to understand who's at the top, who's at the bottom, and how impacting one can affect the rest. But there's also the context of cybersecurity, wherein trying to understand different threat vectors, either in an IT infrastructure or a network topology, are really helpful in minimizing risks and challenges there. By the end of the day, like, why do link analysis? Well, it's a really intuitive and user-friendly way to model your data. Instead of having to rely on these like really large catalogs of different entities or really messy JSON files, you have a really clear picture of the hidden connections that are often lost between these reams of information. and also are able to put into the context of patterns and behaviors that can indicate some sort of nefarious or suspicious activity. It's also a lot more reliable in that instead of like having to use like automated alerts that often cause a lot of fatigue, investigators have more control over the data and how it's actually being explored. The challenge is it's really hard to find good link analysis tools. And I think that the reason of this, based on my own conversations and also from like the decade of experience we've had working with product managers and engineers, is that the three building metrics to executing a good link analysis tool are quite hard to achieve. And I'll go into depth about what these metrics are. The first one is the ability to scale. We all know that OSINT data sets are quite large, and oftentimes the tools that are used to investigate this stuff try to handle multiple different data sets all at once. And if the actual link analysis component can't handle that level of scale, both from a performance perspective, but also doesn't have the design elements that help manage that information flow quite easily, it makes it really overwhelming for the investigator and quite hard to keep up. Additionally, there's the ability to innovate. This is more on the technical side. Oftentimes, the toolkits that are used to build out link analysis components are open source. So that means that people have to build out their own code libraries from scratch in order to build out new features or capabilities. But that incurs a significant amount of tech debt because it's constantly have to build new things over and over again instead of relying on components that are pre-designed in line with investigation requirements. And the other dimension to it is customization. Trying to create a unified user experience wherein the link analysis component feels like it's a part of a broader application that gives the actual investigators more control of what's going on. And again, just kind of touching on why these are so hard, as I alluded to, the toolkits that are used and libraries that are used to build out these link analysis components just aren't usually fit for purpose. And it's not to say that open source toolkits are bad. Clearly not. Like, I think that there's some use cases where it's actually better suited to use something like this. For example, a small internal investigation wherein the people are highly technical, like data scientists, they're just trying to model their data. Or if the data sets themselves tend to be quite small for investigators, there isn't that much of a need for scale. But because a lot of the time the data sets in OSINT are quite large, and it necessarily requires a lot more rigor in building out different capabilities, in order to tackle that data sprawl, the actual SDKs themselves and libraries need to be able to keep up with this as well. And also to allow for the implementation of design philosophies and techniques that actually work with the workflow of the investigator and not contradict them. So in brief, the reason why it's so hard to build good link analysis comes from the technical limitations of the tools available and also the lack of expert informed vision that comes with these toolkits. So how do you make a good link analysis tool? This is a question that often comes up a lot. And when I'm working with product managers or software engineers building out these investigation applications, I always try to emphasize the actual workflow of the investigator. At the end of the day, there's often this impulse to display the data as accurately as possible to the data set, but oftentimes that leads to very abstracted data models that yield very messy graphs. And if we were to then focus on the interaction of the investigator with each node, we can then focus on defining truly what the nodes should be, what the links should be, and use the data itself to create a narrative of the investigation instead of data as data. You're seeing in the GIF right here how the actual nodes themselves expand to reveal different social media accounts. And what we're doing is basically taking the property label of the social media account, the person, and have that as a grouping function. So that way the investigator can group into it instead of having all these different nodes paired around the individual, therefore increasing the user experience. The other dimension to it is thinking about scalability dynamically. So whereas I get this question a lot where people ask me, like, how many nodes can you load into your SDK? And I often flip the question to say, well, how many nodes are actually going to be usable for your investigators? It's important to think about how the data itself will be funneled into the investigation in general, and using things like, as I mentioned, like grouping of capabilities where nodes are based on the shared properties are aggregated together, or using adaptive layouts to help the flow of information expand iteratively instead of just having it loaded all at once. And this will help both touch on one point later on, but also help the end user actually engage with the data in a much more intuitive way. And the other point I was alluding to is performance. Because these data sets are quite large, it's really important to take into account how it'll impact the application itself, but also the time to insight. We often find that buffering times of about 10 seconds are just unacceptable nowadays. And it's largely because the work that the investigators are doing is so sensitive, they need to have the insights quicker. So whereas the raw power of the software development kit that's being used to build a link analysis tool is an important dimension to this, I often encourage teams to think about the design principles that are being applied to ensure that data can be loaded, as I mentioned, either iteratively or just focusing on the information that's actually relevant to the investigation at hand. People can also leverage pre-designed graph algorithms that are informed by graph theory and investigations to actually get to those insights quicker. And I'm going to welcome you over to my desktop and show you an example that that is actually within the SDK site for Keylines itself, which is our JavaScript library for graph visualization. So just to be very clear, this is loaded within the SDK site, as I mentioned, but based off our own libraries. So it's not necessarily like an investigator tool, but something that people that are building out their own link analysis components or want to improve upon them would use for this purpose. So the example that we have here today is social network analysis. And what we're visualizing is a data set of different emails and individuals associated with them and the activity to it. Now, this organic lid of a graph kind of gives us some loose information. There's some loose clusters over here and some people that seemingly operate as vectors of information. But if I'm an investigator, it doesn't tell me as much information as it could if it was using something like a graph algorithm. So what I'm going to do actually is click on the PageRank here button here. And what I've basically done is leverage the native algorithm in Keylines to calculate the importance of these individuals based on the links connected to them. So right off the gate, I can already identify that Tamara Black is clearly someone that I should be spending a lot of time focusing on because she has so many people that are reporting directly to her and connected to her. Whereas some of these folks that are obviously off to the side, or maybe just receiving some information, as you can tell from the direction of the links, likely aren't as important. That being said, that's just one example here. If I wanted to, say, for example, identify the betweenness of different nodes to understand who are, as I mentioned before, like the middle people between different clusters of nodes, I can then have a better understanding of who may be trying to coordinate multiple different clusters to potentially collude in some sort of nefarious activity. There's other algorithms that we use as well to kind of improve the process of investigations, like agent centrality, to understand where the most dense cluster of activity is, where these are people that are likely should be prioritizing the investigation to understand the maximum area of effect that then affects the rest of the network. Again, these are just some examples of what can be implemented using the toolkit. And I'm really excited to pass it over back to Brett as he's going to then showcase to us Videris, which I think of as a very strong example of a good application of link analysis for investigations. You might want to go turn off mute, Brett.
Thank you very much. There's something I'd like to ask you before we move across to the next slide. And I think that's quite key. You mentioned something in there that was, it's a necessity for an investigator. What applications or what do you see in terms that are out there within the sphere at the moment? How do Cambridge Intelligence differ themselves from other organizations that are able to visualize intricate networks or connections?
Yeah, no, that's a great question. Thank you, Brett. I think the key difference between ourselves and either organizations that have their own internal tools for visualizing solutions or applications like Videris that have native capabilities to visualize different data sets is that we're really just a developer toolkit. People can take the libraries that we have and build out their own visualizations according to their use case and have a higher degree of flexibility of what they're trying to achieve. You know, most of the organizations that I work with have a pre-existing link analysis tool on their product, but are either facing challenges with like scalability or improving the overall responsiveness and user experience. So they would likely choose to use us over open source just because in order to tackle those specific problems. Whereas if it's, you know, if user experience is that live a priority, or if scalability isn't that much of a challenge, or really not a priority as well, that's where like an open source toolkit, like those you'd find like Cytoscape or D3 would make more sense. So I hope that kind of differentiates where we kind of sit in the market in general.
Yeah, no, definitely. I think that's incredibly insightful for an individual that's been an investigator for many years. I think there's still some things that I think wow me when I see them, and that's certainly an element of what you discussed there. So I think that was truly insightful and deeply appreciated. So thank you very much. That leads me on to this next slide. What does Videris do? So as I touched on before, Videris was built particularly for the intelligence community, and more so how we can conduct complex investigations, merging various data sets from locally and globally, data repositories, but how we're able to visualize this in a constructive way. So we are specifically designed to meet the challenges and the needs and the functions of economic crime investigations. Now, what Videris does is Videris integrates OSINT methodologies like link analysis, as we've just seen, and a wonderful presentation there from Alejandro, and then I'll show you afterwards how that works in Videris, but also how we fuse data and contextualize analysis into a user-friendly platform. It's super, super easy to use. We can do things like search, analyze, and visualize, where we're able to look across the deep and dark web. We can run hundreds of searches and highlight key results within seconds. We're able to scale social media and securely. And what I mean by securely is that your digital footprint is safe and secure while you're using the platform. We can map complex networks and overlay this, as I touched on previously, with other data sources. I think to help and identify those hidden connections and effectively those layers of the apple core that we touched on previously. We look across various corporate data sets, and some of these are free and some of these are premium sets as well. We look across PEPs and sanctions lists and data to investigate entities, again, to help layer or add on any of those elements of risk that we can. We're able to search across internal data and custom sources, so we can integrate things basically from CRM, but we're also able to investigate those alongside other data analytics that we have within the platform. We're an end-to-end tooling, so we combine OSINT data gathering, filtering, and link analysis, and report this all in a single window. I think, as Alejandro touched on before, when we look at illuminating that intelligence in a single pane of glass, that's very much where we see Videris sitting. It utilizes advanced automation, speed of need. Effectively, that's one of the biggest things that we see within investigations at the moment, how quickly, securely, and accurately we're able to return that information. We've got actionable visualizations. And what I mean by an actionable visualization is that we can provide interactive, so you're able to move it around. Again, we've seen previously in Keylines technology, but real-time visualizations of those networks, and we're adding more complex data sets to those. We're able to look beyond the layers of just that individual, that network. What that leads me on to is the last piece, is that it's customizable and secure. We offer tailored workflows with options for secure, previously on-premise solutions, but now we are a web-based application server. How can you enhance economic crime investigations with Videris? So we're designed for targeted understanding of individuals and networks. What this is, again, this links into previously with network visualization. So link analysis, utilizing Cambridge intelligence technology, works with the automations and some AI, natural language processing that's embedded within the background of the software for us to be able to get a deeper, richer understanding of those networks that we're looking at. We work with customers from public sector and the private sector. We work with many different agencies within those, from governments and banks. So our use case and our understanding of how we built this product and why we built it in this particular way covers many different realms of organizations. We're data agnostic, so we offer a huge range of global data sources that I've previously touched on. And the reason and rationale behind this is that we are trying to aid the investigator as much as we can. I think with the link of Keylines technology, we're not looking to replace human beings. That's certainly not something we're looking to do. But what we are looking to achieve is being able to provide investigators with that single pane of glass and to give them the tips, particularly using things like risk insights and similarity, what we're going to go through next. What this will lead me on to is we're going to give you a brief demo. And what that is we're going to be able to look into how this is fused together. So we're going to use the intelligence we input within the software through Videris, but we're also going to see how we're able to visualize that utilizing Keylines technology. How this would naturally look is that we would start investigating a subject. So this could potentially be a case from an economic crime case when we've had a SAR that's come in, a suspicion activity report, and we want to look into that. We can look across various sources, such as corporate registries, public records, social media, and big web and news. We can do this all simultaneously, so that works in the background. And as you can see, it's taking the context that we've input from the chart, which was Stuart Pallethorpe and an individual that's based from Norwich. Once we've input that information, that will allow us to obfuscate various other pieces of information or data that aren't relevant. And as you can see, we've produced that 186 results out of 550. As you can see with the Stuart Palathorpe, and in particular the second entity that was linked to the chart had Norwich, and also the one previously above that with a LinkedIn profile had Sentinel Properties. We can pull this information back timelessly, again, at the speed of need, but it's going to connect that in one place in an easily visualized way to be able to look at that. As I said before, we can go through social media, and as you can see, we're looking through the individual's LinkedIn profile here. We can also pull in that corporate ownership structure, but we can change the layout in terms of how we want to visualize this, again, using Keylines technology. These automatives are particularly helpful because, again, as I touched on previously, when we're looking through messy organizations, this can potentially lead us to go down a rabbit hole. Now, as we can look through the explore functionality, we can look through the individual's social media profile through a secure window without a digital footprint, and that will allow us to have a pattern of life or to look into the individual's daily activities if they put anything on there where they've gone. Once we start adding those corporate registries to our data, we're then able to expand that network out and have a look at the individual, the business, or are there any other individuals that he's connected to. Now, as you can see, we touched on previously on the LinkedIn, there was Sentinel Property Investments. But we've also got an interesting company here that doesn't look like property management, which is called Aquatech. Now we've got an element of where possible risk has been associated with this individual. And what this will allow us to do is be able to go in and investigate that risk further. This goes back to the point that I made earlier, that we're looking to aid humans, analysts, investigators, as much as we can with these potential tips and nods to say that we think there's something here you need to look for. As we looked for possible risk investigating this individual, as we can see and going through and looking at this big news media story, that this individual in particular is connected to what appears to be a drug smuggler or narco trafficker. Now, we've pulled that back in a relatively quick time, but we've been able to visualize that in a secure browser, but we've also been able to visualize that in a structured way that helps us layer through those nodes and weeds and to be able to identify relevant realms of particular interest and pertinent to our investigation. We can add those search results to those individuals, and then we're able to abstract that data at the end of it into a report or format, whether it's PDF, PNG, or we can pull the data back itself within a CSV format. And just like that, within 3 minutes, what we've been able to do is identify there's a potential risk in terms if this was the SAR report that I've mentioned earlier, or we may be doing EDD on an individual. We can then disseminate that report internally if we needed to look at risk and to be able to highlight and elevate those areas of concerns. So within 3 minutes, what we've been able to establish is to visualize a complex network of individuals, but identify the risk that was associated with the individual at the start. And that is the end of our demonstration. So I'll stop sharing. And at that point, I think if anybody's got any questions, please feel free to put those into the chat box and we will go through all. Myself or Alejandro will start answering those. So Alejandro, I think this is a good question to ask. And we've got, how well does link analysis scale as data sets grow?
Yeah, I love this question, actually. Thank you for sharing it. Thank you, Alex.
Thank you.
I think that link analysis scales as well as it's built to scale, which I feel like is a non-answer. But what I mean to say is that it's important that as data sets continue to grow, that if you're designing any kind of link analysis component in your solution, that you have features and systems in place that can help grow with that data set. So this is going to get a bit technical, but bear with me. So one of the ways that we encourage people to use keylines, for instance, is leveraging two things. Combos, which are the aggregating different nodes based on the shared properties that you kind of saw in the GIF earlier, and also lazy loading. And one of the reasons we encourage people to use that is that if you're loading a whole bunch of large data sets, but are able to aggregate all those into by shared properties, and then implement lazy loading, so that way you have one layer of nodes, or groups in this case, displayed, but then another layer behind it already preloaded. You can then, as you drill into these data sets, iteratively load more on there to make it easier for the investigators to see what's going on without overloading the system itself. So I think that it's all about like designing the system in a way that will help work with data sets, or what you anticipate the data sets will look like. And there's also ways as well to like have multiple different databases synchronized by offering filtration options. So like even simple toggles can help with that, and using appropriate layouts according to the data set.
And I think leading on to that, I think I've seen another question on the back end. Lots of software offer charts and tables, but at what point would they benefit from working with graphs?
Yeah, that's a really good question. I think that graphs, like network graphs, link analysis, makes the most sense to use when you're dealing with very messy data that's inherently interconnected and complex, and any data set related to where you feel like you need to be investigating the actual data set. That's where graphs make more sense. Whereas if you're just like calculating percentages or dealing with like BI stuff, that's there are instances where like a graph may be suitable for these, but it's really where the investigator needs to be able to feel like they're in the world of the data, where a graph actually makes the most sense. And for anyone that's interested in kind of exploring if it makes sense to start exploring adding graphs to their either product stack or their workflows, I'm happy to jump on a call with anyone to kind of understand, unpack what those workflows look like in more depth. But yeah, long short of it is, if the data is complex and interconnected, and the end user needs to actually investigate it in a lot of detail, that's where graphs and network graphs really work out.
I think just if I take on board the next question, how do I make sure that OSINT investigations remain ethical in this context? So that's the bread and butter of the industry, ethics within open source intelligence, because there isn't governance and framework, this can often get quite murky. The first piece of advice that I ever give anybody in conducting investigations on people, networks, or organizations is making sure that you're not going on the realms of accessing anything that isn't public. So public facing information is exactly where we are within the industry and what we expect to see. Anything beyond that in terms of using passwords or getting into groups or potentially anything that borders on the lines of surveillance, I would certainly steer clear from. I think we may have had another question. How many node group layers deep have you found is valuable typically before you begin to encounter diminishing returns in investigations? That's very interesting. I think we could both give a take on that. Alejandro, if you'd like to go first.
Oh, that is a really good question. From my experience, this is like a bit of a cop-out answer, but it really depends on the workflow. I think that you can have a large layer of granularity when it comes to combos. By the end of the day, or like grouping nodes in general, by the end of the day, it depends on what the outcome of the investigation looks like. I actually had this situation where I was working with a customer that basically was struggling to identify how they should even define a singular entity that had multiple shell organizations associated with that. And intuitively, they wanted to like lay everything out, but we encouraged them to think of like using that kind of initial entity as a grouping factor for these shell organizations. Obviously, you can drill down into a rabbit hole, but I think that the benefit of grouping nodes in the first place is that you can start off with a macroscopic layer of scale and then drill in according to the requirements of the end user. Yeah, I think that thankfully with most investigations, there are lowest common denominators that are included here. So like individuals, associated records like phone numbers and addresses and whatnot that help it be grounded. And very rarely is there a level of granularity that's too in depth. That's more in the realm of like cybersecurity. And even then, there is a limit to how far the rabbit hole can go. If there are instances where it becomes that layer of complexity, I think that's where you need to start reassessing how you're defining nodes.
Great, thank you ever so much. I think my element or my take on that in terms of conducting investigations is that, and you touched on this quite loosely, is that you have to stick within the realms of what that hypothesis was. Now, it's okay that the hypotheses can change, but I think if you come into this being able to visualize data, as we touched on before, it can become quite messy very quickly. And I think that when you have those core entities or those core subjects of interest, I would certainly say not to go 2 or 3 nodes beyond those individuals, because what will start happening is that you're moving further and further away from the focal point of your investigation. I think enriching or further scanning for things such as social media profiles or telephone numbers or email addresses are fine and okay as long as they restrict to that entity, because they'll physically still be attached to that node. So I would certainly say that it all depends on the hypotheses. If you're looking into a sanctioned entity, you have the ability to go so many nodes further on, because for the fact that they would have done layering, proxies, shell companies, and all of these other entities to be able to obscure and hide those trace of funds. So I think it's very much led by the hypotheses in that investigator, but I certainly don't think there's a standalone answer. It all depends on what you're looking to find or what you believe the hypotheses to be at the start. Another question: how does link analysis fit into an automated and AI ML driven data process, Alejandro?
Yeah, it's especially nowadays where like generative AI is becoming like the hot button subject. I have really strong opinions about AI, but I'll reel it back in. So I think that link analysis serves as the point where the investigator actually has the most control over the processing of information. Ideally, you'll have, obviously solutions like Blackdot offer really smart usage of automation, like intelligent automation, which helps basically the process of like filtering information in a way that's a lot more concrete and helps cross-referencing things. And ideally, you would have already done some of that AI and automated processing before reaching the point of link analysis. Now, there are some cases where people are trying to explore maybe using generative AI on the side with the link analysis component. So that way you can have a prompt where it says, hey, can you help me, see all the connections of like Red Redmond to Alejandro, and then generate a prompt from there. I think that's already going a bit further beyond what's capable, but it is something that is on the horizon. People are starting to investigate it in general. So I'd say as it stands presently, you will ideally have machine learning tooling or AI capabilities that can help generate insights on the data that can then be represented on the link analysis component. So it helps basically steer and navigate those insights that are surfaced from AI. I hope I answered that question clearly and directly.
Yeah, definitely. I think so. I think one of the points that I was going to make off the back of that is that being able to visualize networks is one thing, but I think analytics on the back end of that it is also the insight or the element that people are looking for. And I suppose 5 pence on that is that I think that with AI, is there a boundary of where it's going to be able to cross and it doesn't entwine or talk to that network or visualization that we see? And there's the potential of being able to muddy that investigation.
Mm.
Brett, have you found any good ways to use AI in OSINT investigations? Um, Actually, yes. I think this is an interesting conversation, or an interesting question, should I say? Yes, I think that particularly, as I've just alluded to there, when we're looking at complex networks or we're trying to visualize them in a particular way, it can get rather noisy. And I think it's very easy to move away from the hypotheses. What AI has been able to produce for me sometimes away from platforms in particular, and when we're looking to structure data, is that it's been able to find specific stories or specific pieces of information, again, at the speed of need that I need for a relevant investigation. If I am looking into a sanctioned entity who may be 2 or 3 layers removed from an organization and I can't find a connection between him and an individual, what AI was actually able to produce for me was that tell me that one of these organizations had been sold, and it gave me a direct link to where this individual had removed information from the internet, and I was able to find this via the Wayback Machine. Again, that was from a manual process, so that was certainly something that was a bit of a eureka moment. So I am still on the cusp of AI, but I certainly can see a need for it more in terms of investigations because of automation and how fast we're going and the sheer data and volume that we're able to access publicly. It's certainly going to be something I think that goes hand in hand moving forward with investigations. Does Keylines regraph have the ability to apply different weights to edges and group nodes accordingly, e.g. machine learning confidence factor? Good question.
That is a really good question. So there are ways to basically customize the thickness or the actual like look of the link itself. In the libraries themselves, a lot of different ways and components that you can then use according to your workflow. I didn't show it in the actual social media analysis demo, but we do have a little toggle that basically helps increase the thickness of the links themselves according to the volumes of emails that have been corresponded with. So in the context of like machine learning, like confidence score, which obviously like if you're calculating like say for example, risk factors on a node or potential like groupings based on the actual, in some cases like distance traveled, there are ways to customize that so long as the actual insights surface from machine learning are structured in a JSON file. And obviously like our technical teams work really close with engineers to better suss out how to apply that in a way that's like scalable.
Awesome, very good answer. I certainly don't think that's something I was going to be able to answer, Alejandro, so I really appreciate that. Are there any more questions? It would appear that if there's nothing else that comes through, that we run dry in the Q&A session.
I might have a question for you, Brett, if that's all right.
That's absolutely fine. Fire away.
I love Charlie's question about like how you've actually used AI in your investigations currently, and I'm wondering, there's we've alluded to how at the end of the day, like we want to empower investigators to create insights quicker, and it sounds like there are ways for AI to do that. I wonder, in your perspective, what would you say is the kind of limit or dropping off point of the usability of AI when it comes to investigations in general?
Oh, I don't want to go down a rabbit hole here.
I
This has
know
been
that's a
an
hard one to
extensive conversation. One of the things that I've struggled with, in particular with AI when conducting investigations, and there's two components to this. One of it is the verification and the reporting and factual information. So I think one of the information that, sorry, how the information is returned, I also need to verify that information. Now, I'm not saying that I want to speed up my investigations and use this from a manual perspective, but I've also found from reporting perspectives as well, being able to provide analysis on whether it's web pages or whether it's a CSV file that I've ingested into a particular platform, it often doesn't construct it in the way that I see it. So I wouldn't say that I'm risk adverse with AI. I certainly have seen good examples of where it's been able to return information, or it's aid and assisted my investigation. But I think I'm a little bit arm's length at the moment from a trust perspective. So I certainly think that the two pitfalls that I've seen with investigations, and where I think it needs to advance further, and I think it will within the market, is one, the misinformation and disinformation. So the information that it returns, is it accurate? Can we verify this? And where has AI pulled this information from? That's one layer. I think the other, again, is the network and visualizations of being able to prize these together into a report and functionality, so that can be disseminated and used on the back end of any investigation. Hopefully that answers your question. I think it's quite AI is something we see a lot, specifically within investigation. I think we just need to be cautious how much trust in a certain perspective we put into it.
Yeah, no, I think that's a great answer. Thank you.
I think there may be a couple of questions that have popped into the chat. No, I can't see. I think that may be the end. I can't see. One question: a lot of public data is in pay-per-view libraries. How do your tools handle this? So specifically, a lot of these or public data in pay-per-view libraries, it will be an API key. So the API key is ingested within the platform. That means that we can have access to a particular set amount of enrichments or searches across these particular streams. And it's almost like a top-up process. If you wanted more, you'd have to buy more credits. This is industry norm and practice, and this is how they work. Unless you buy the full API key, and then you can have complete access. Sometimes these are restricted to a particular amount of searches, and sometimes they're unlimited. It just depends what organization or data set it is that you're trying to view. I'll just check that we don't have any more questions. And I believe that has taken us to the end of our presentation. So hopefully that's been insightful. Alejandro, it's been a pleasure. Is there anything you'd like to share before the end?
No, it is likewise a pleasure. And thank you everyone for your questions. They're really insightful. I really appreciate it.
Thank you ever so much. Our emails will be shared, or you can reach out to us directly on LinkedIn and to be able to find us if you want to discuss something away from the webinar. But thank you ever so much for your time. It's been incredibly insightful, and I've enjoyed the pleasure and presence of everyone. Thank you very much.
Have a great rest of the day, everyone. Cheers.
Thank you. Cheers. Bye.